Hi, this is Mr. Nazarian. Our lesson objective today is I can understand and explain the value of digits in larger number, 5th grade standard numbers base 10A1. Today we're going to focus on reading and writing larger numbers. This is a place value chart, and it shows all place values from the ones place all the way up to, we're going to go up to 100 billions place today. So big time. You remember from yesterday and what we were practicing today, each of these places can only hold one single digit each. What we're going to do today is we're going to look at some large numbers and be able to write them. We're going to look at them as words, read them, and then we're going to be able to write them numerically. So, 65. This one should be pretty darn basic for you. We're going to start, we'll do this maybe a different color. So remember 65, we cannot write 65 right here. And that is because 65 is how many digits? It's 2 digits, right? And we only can have 1 digit in here. So that means that, remember, a 65 means that there's 60 and there's 5. And 60 is how many tens? It's 6, right? So 65 is going to look like this. A 6 in the tens place, a 5 in the ones place. There's 65, right? No sweat. Now we're going to get a little bit bigger though. 2,407. So 2,000, that should tell us there's a 2 in the thousands place, right? So 2,000, what was it again? 2,407. So 4 in the hundreds place, right? 2,407. So should we put the 7 here? Because it should go right after this number? No. It says 7, not 70, right? So that means it's just going to be 7 ones. Now what about this gaping hole right here? Does it say anything about any value that would be in the tens place? 2 in the thousands place, 4 in the hundreds place, and 7, just regular old plain Joe 7. So that means that there's nothing in the tens place. So what digit represents nothing in math? 0, right? So 2,407 looks like this. Now, as we look at these, this place value chart, you'll notice that we have ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, billions, 10 billions, 100 billions. If you notice this pattern here, and especially if I said, because you could say 1,000s place, 1 million's place, 1 billion's place, is that it has this repeating pattern of ones, tens, hundreds. The only difference really is as we move into what I like to think of these different houses, it's like each of these is a family, and then each of these is like another house in the neighborhood. This is like their last names, right? So we still have ones, tens, hundreds. Ones, tens, hundreds. It's just that these different houses have different last names. So this family has no last names. We're real familiar with them. Ones, tens, hundreds. But then we move over here and we've got 1,000s, 10,000s, 100,000s. This is like the thousands house, right? And then this is 1 millions, 10 millions, 100 millions. This is the millions house, and then they've got the billions house over here. And so, just like, you don't want your neighbors, living in your living room, we separate them a little bit, and we separate them with commas. So we've got these commas in between here. So typically you'll see a comma between the thousands here and the hundreds. Okay, so let's do a few of these. I can try to go a little bit faster. So we've got 36,540. So 36,000 tells us that's going to be in the thousands place, right? So 36, I can't put both of these in this thousands, right? It can be 36,000s. It's got to be, remember, only one digit here can go here. So that means that we're going to have a 3 in the tens thousands place, because that's going to give us 30 thousands, right? 3 tens, 30. So 36,540. So we're going to have the 5 in the hundreds place, right? And what's 40 made of? It's made of 4 tens, right? So we're going to put 4 tens. And is there any mention of any digits I should put in the ones place? No, it's just 40, right? So that means we're going to put a 0 here. There's 0 ones. Okay? Again, we want to separate the neighbors here with this comma. Okay? Give them a little bit of space. So, and I want you to think about something here as I read these. 2,407, 36,540. I did not say 2,407. I did not say 36,540. And the reason for that is something that we'll work on a lot more throughout the year. We'll begin working with decimals, and that is the only time that mathematicians say "and" is when we're talking about decimals and fractions. So this decimal point, when we start using decimals, that's going to be the "and." Okay. So when we're talking about whole numbers, we don't say "and." All right. So let's move through here. So the next one is 12,087,693. 12 million. So that means 12 is going to be, we're over here in the millions house. 12 is going to be, can't all fit in the millions, right? It's 2 digits. So we got to have 1 10 million and 2 1 millions. That gives us 12 million, right? So we've got 12,087,000. Were there any mention of any 100,000s? No, just 87,000. So that means we're going to have 0 in the 100,000s. And then we're going to have 87, which means 8 tens makes 80, right? And 7 in the thousands place for 7,000. And I just can't remember these. 693. So 6 in the hundreds place. 90 means 9 tens and 3. Not and though. Okay. And last one is a whopper. 775 billion. So we're going to be over in the billions house, right? 775. So we're going to go over here to the billions. Let me just change colors here. 795 means 700s. 90 means 9 10 billions. 5 for 5 billions. 324 million. So we're going to have 300 million, 20 million, which is 2 10 millions, and I'm sorry, 24 million, so 4 millions here. 688,000, so 600,000, 80,000, which is the same as 10,000s, and 8,000. Whoops. Let's get another comma here. And finally, 104. So 1 in the hundreds place. No mention of anything in the tens. 4. 4 ones. So there we have 795,324,688,104. All right, so that's what writing out large numbers when we're reading them looks like, and we'll work more on that tomorrow. See you then.